Now, previously we looked at a question which was to do with launching a cricket ball, and the cricket ball is launched at 30 degrees above the ground at a speed of 28 meters per second. And so we're going to be looking at question 9. What horizontal distance does the ball travel before landing? That is, what is its range? Now, because it's at ground level, we will imagine that its displacement is back to 0. So we've got the vertical and we've got the horizontal. And what we are told is that it's, I'll just put UVAST, UVAST. I like to keep a tabs of all of those variables. Now we know the vertical was 28 sine 30, and that's 14 meters per second. And the initial velocity was 28 cos of 30, and I'll just leave it at that because it's approximately. If we change it, now the velocity, the acceleration is down at 9.8 meters per second squared, and there is no velocity acting in the horizontal. And we're after the displacement when the time. What are we after? The range, right? So what horizontal distance does the ball travel, and what is its range? Well, we want its vertical displacement to be 0 meters. So that means it's gone up and it's come down to be at the same level that it started. So its vertical displacement is in fact 0 meters. So once we've got the time, we can then put the same time in here to find the horizontal distance. So that's S of H over here, S of H, and this is S of V. The vertical is 0. So let's look at the formulas we've got, combining S, A, and T. And we can say S equals UT plus half A T squared. We don't know its final velocity. We can't use V squared equals U squared. We could, and V squared is U squared plus 2AS. We could use that and then use V equals U plus AT to get the time. That's fine as well. So you can combine those. I'm just going to go straight into use S equals UT plus half AT squared. So 0 equals our initial velocity is 14 T plus half of A, which is negative 4.9 T squared. And so 0 equals, factorising T out, 14 minus 4.9 T. Therefore, time equals 0. That's true. It's at displacement 0 at initial. And 14 minus 4.9 T equals 0. Therefore, 14 equals 4.9 T, and then divide that 4.9, 14 over 4.9. That's the time it's back to its start. So we've got the T, which is good. We're on our way. So 14 divided by 4.9, and that gives about 2.86 seconds. I'm going to leave it as 14 over 4.9 because that's exact seconds. And now we come over here and we find our displacement using the same formula. S equals UT plus half AT squared. And it's our initial velocity, 28 cos 30 times T, 14 over 4.9, plus half of acceleration times time. Now, because acceleration is 0, that's plus a 0. So 28 times cos 30, and then times 14 divided by 4.9. And that is it will reach 69.282 meters. That's to 3 decimal places, and I'll just put an approximately here. And there we have it. I hope this has helped. Until next time, stay happy.